Hello everyone, welcome to the UCalgary iGEM's team's first ever podcast, The Science Really Work. My name's Khadija Abbas, and today I have the honor and privilege of talking with Dr. Jason Donev. Dr. Donev is a tenured professor here at the University of Calgary and is well known within the physics department. He's won multiple awards for teaching and is known for his public outreach and encouraging attitude. I know this firsthand because I had him for my first ever physics class. It's a pleasure to have you, Donev.
Thanks for having me.
Yeah, I remember when I took your physics class during first year, I was going in really excited, but I also felt that there was a lot of things that I should have known, but possibly didn't. So whenever I asked a question, I felt that maybe the question was like stupid. But I remember your attitude was really amazing. Whenever I asked questions, I felt encouraged to ask more. So I'm really excited to ask you even more questions today and take everyone along for the ride.
Sure.
Yeah, so for today, I wanted to learn more about, since we're in Alberta, energy is such a big topic, right? So, and I know that you do a lot about energy and climate change. Would you mind letting us all know a bit of your background?
So I'm a physicist, and one of the things I discovered while I was going through my physics program as an undergrad, as a grad student, was that physics ties to all these different areas of our life. And oftentimes, the way it was explained to me is that physics will often tell you what's possible, as opposed to like economics, which is like what we should do, and politics, which is what we will do. Physics at least gives you some sense of what is possible. So to answer the question about your podcast, does science work? And the answer is it absolutely does. But what that means isn't quite what people think it means. So one of the things I got interested in once I finished my PhD, because I had spent several years locked in an underground laboratory in the name of science, chained to a microscope, sitting there, carefully counting all the molecules moving around on my surface and so forth. And I went, I like people. I don't want to spend the rest of my life chained in an underground laboratory. And I started looking in a lot of details as to what is science and why do people believe weird things? And when science does actually come up with a very, very definite, look, we're confident about this, why do people not internalize that? Why are people's emotions and other experiences overwhelm what it is well known to be true? So being true isn't enough. There's this almost truthiness about things where people are like, sure, I know science says blah, but what I really know to be true and the actions that I take on being true are based on these other things. So we're seeing this with climate change. We're seeing this with nuclear power. We're seeing this with genetically modified organisms, GMOs. We're seeing this with evolution. Evolution is one of the most well understood, well established ideas within science, and yet people still reject it all the time. So I got really interested in why do people believe what they believe? Because this very question that your podcast attempts to ask, and thank you, it's quite an honor to be invited for your first one. It's fascinating to me, not just does science work, but why is that even a question? So my background is I came up through physics, and then when I came to the University of Calgary, because energy is such a hot topic everywhere, and specifically here in the province of Alberta, the city of Calgary, energy as a topic is just so crucial to everything that we do. And I'm sure over the course of this entire conversation we'll unpack a number of details about that. I am now the Associate Director of the brand new Energy Science major that is launching this September in the newly rechristened Department of Earth, Energy, and Environment. We're the second E of the triple E. And we're really excited because we had over 100 students apply to this brand new program. We didn't even get the advertising out, and this was my bad. The university did a good job on this. But we're starting this brand new energy program, and we're just so excited to talk about the science of energy. And that's what I'm spending a lot of my time doing.
That's so interesting to hear. I think we touched on a lot of very, very interesting things. One thing that you mentioned is how climate change that's going around right now, and there's such a public perception that I feel like especially now, especially with a lot of right-wing media saying that it's not that really big of a deal. Why do you think that is? Why going like, why do you think people are now talking about climate change as if it's not too big of a deal? Is it like something going on like social media, or do you mind elaborating a bit on that? Or
Okay, so a number of things. One, climate change and global warming, I'll distinguish those two, is real, it's bad, it's us, it's time we do something about it, and there's reason to hope. There is actions we can take that will make it better. We have to choose to do so, and the more we choose to do so, the more we mitigate climate change. Global warming is one part of climate change. Global warming is the entire planet is, on average, getting warmer. So, I mean, kind of obvious from the name, global warming, the entire globe is getting warmer. Climate is not weather. Weather is what's happening at any given moment. Well, climate is a long-term average of the weather. So it's raining, it's cold, climate's still changing, the world is still getting warmer. But on average, the world is getting warmer, while when we're talking specifically about a particular day, that's weather.
okay,
So the climate is shifting. It is difficult. One difficulty just right out of the gate is it's difficult for us to experience climate when what we are trained to experience is weather. Okay? So the difference is, do I bring an umbrella today? That's a weather question. How do I build my house to make sure that it is appropriate for all the weather for the next 50 years? That's a climate question. How do I build a house? How do I build a city? How do I build an entire infrastructure for society? How do we make sure that we continue to have enough food? That's a climate question. Is there enough rain today for the crops, or am I going to need to do some sort of irrigation? That's a weather question. Okay? So they're tied together, but the long-term scale of what happens with climate is kind of outside the natural way people think about things. It's difficult for us to think and to have emotional responses to things that will take decades to centuries to happen. So that's one piece of why climate change is so difficult. Second piece is it's not just the right-wing media that's actually getting climate change wrong. The left is also getting a lot of things about climate change wrong as well. Not as much, truthfully. I'm not trying to equal it all out and so forth. But there is a very vested interest in people saying things like, I don't want to change. And the more people have power, the more people don't want that power to go away. Somebody summed up the difficulty in a wonderful little phrase. There are some fools who believe that this is old and therefore good. And there are some fools who believe this is new and therefore good. And the ones who believe that this is old and therefore good will often wind up believing things like the world is simply not changing, it's not going to get any different. Where people who are focused on this is new and therefore good are often focused on everything is going to change, where some things actually do wind up staying more or less the same over time. When we are talking about a significant change in the way the world's climate and local climate, so for example, over the course of your lifetime, I'm going to guess at what your age is, but say roughly 20 years, plus or minus, over the course of your lifetime, Calgary has gotten warmer. That doesn't mean that Calgary will never have another cold winter, but it does mean that if we look at the winters today, and we look at the winters of your childhood were in fact colder. This leads to all sorts of jokes about, uphill in the snow both ways. Well, we did actually have more of that cold weather decades ago. The amount of snowfall that we wind up having winds up changing as well. Now, this is where things get really tricky. So, the first piece is it changes over such a long period of time that it's difficult for people to wrap their mind around. The second piece is there's this vested interest, specifically within people who are conservative, in wanting to believe that everything is going to stay the same. And there's a vested interest in people who are very liberal in wanting to believe that the world is going to continue to change the way they want it to, which is also not necessarily true. But this third piece, when it comes to climate change, is it's really complicated. Climate change cannot be meaningfully brought down to a GIF, a meme, a tweet, a catchphrase. or even a TV show, or even a single movie. So, An Inconvenient Truth was a really, really impressive movie that Al Gore put together to talk about climate change. And I'm really impressed as a science communicator looking at what it was he did over the course of that movie. He got some things wrong because, I mean, he's fallible, you know, but part of it is just a matter of he was trying to get all of the cogent, salient points down to something digestible. Climate change is too big to reduce down to salient points and still have all of the nuances of what's happening. Now, my favorite salient points about climate change are, it's real. We know it's happening. It's bad. It's going to hurt everybody. It's going to hurt some people more than others, but it's going to hurt everybody. It's us. We are very, very, very clear that the reason the climate is changing is we are emitting a huge amount of carbon dioxide and other greenhouse gases into the atmosphere. Most of those greenhouse gases, carbon dioxide, are coming from burning coal, oil, and natural gas. And the number 4 is the CO2 that is emitted from the cement-making process in making concrete. The amount of CO2 that we put into the atmosphere is gargantuan. It's difficult to wrap your mind around. So, for example, you're familiar with how big an elephant is.
Yeah.
Okay, an elephant weighs roughly 4 tons.
Okay.
And you're familiar that elephants can stack on top of each other. Right?
Never seen that happen, but I'll believe
It's an
you.
old circus trick.
Okay.
Right? So, if you could imagine a stack of elephants, now no elephant would be able to do this. So you stretch the stack of elephants. So 1 gigaton of carbon dioxide, 1 gigaton, just the weight of 1 gigaton, is elephants stacked on top of each other from here to the moon.
That's 1 gigaton.
That's 1 gigaton.
1.
So we emit roughly 36 gigatons of carbon dioxide per year, we being the planet.
Oh.
So this means that roughly every 10 days, the amount of CO2 we're putting into the atmosphere is a stack of elephants stretching from the Earth to the moon.
Wow.
If you don't really have a good sense of how far, like, we can unpack this in a different way. The amount of coal that we burn in a year. You're familiar with trains, right? Like the trains carrying coal around.
Mm-hmm.
So your standard rail car holds 10,000, 100 tons.
Okay.
And then your standard train is roughly 100 cars long. So that means 10,000 tons of coal in one single coal train.
Okay.
When the province of Alberta was still burning coal, which was, roughly 2018, 2019, right? Like relatively recent memory.
Okay.
Right? Like you were probably in high school at the time.
Yeah.
Right? The amount of coal that Alberta was burning. So you got this idea of how long those coal trains are.
Mm-hmm.
It's kilometer long. Mm-hmm. That's enough coal for Alberta for 6 hours.
Wow. Huh.
That's just Alberta. So that much coal in 6 hours. So the coal that we would burn over the course of a year, just here in Alberta, would stretch from Calgary, where you and I are sitting having this conversation, through to Sudbury, Ontario.
Wow.
That's just Alberta in 1 year. When we're talking about the global coal consumption, if we put it on a train, it would stretch all the way around the planet 40 times. Global annual coal consumption for the planet goes around the planet 40 times.
Wow.
The mass, the weight of oil that we burn is pretty comparable to the amount of coal we burn. Just, blur your eyes, big round numbers. It's very similar. And the amount of natural gas that we burn is, again, very similar. So when you start talking about that much fossil fuels being burned, you can start to wrap your mind around how you're emitting a gigaton, elephants from here to the moon, of CO2 every 10 days. It's difficult for us to wrap our minds around that. And it's difficult for us to wrap our minds around the complexity of the problems that causes. For example, that much CO2 in the atmosphere winds up trapping infrared radiation, greenhouse gas, winds up warming things up overall. But the CO2 in the atmosphere also does things like ocean acidification.
I didn't know that. Oh.
So Yeah, ocean acidification is kind of global warming's bigger, not actually less evil brother. Under less, not necessarily less evil brother. So when you wind up having this huge buildup of CO2 in the atmosphere, the CO2 interacts with raindrops before it falls down. And those that makes, so this is different from acid rain. Acid rain's a more localized phenomenon.
Okay.
But when you have CO2 in the atmosphere going into the raindrops, that's falling into the entire ocean. So you're winding up taking the entire ocean's pH, how acidic it is, and you're making the entire ocean's acidity change.
Oh.
If it changes enough, we'll see an entire collapse of the entire ocean ecosystem.
All the fishes. No.
Well, it doesn't start with the fishes. It actually starts with a lot of the stuff with exoskeletons.
Oh. Okay.
Or just because of the chemical reactions that you've got. But what eats the stuff, the little tiny things that you can't even see, what eats all of those? Well, that's the fishes.
Oh. Okay.
So, somewhere between 1/10 and 1/7 of all people in the world get the majority of their protein from fish. So from my perspective, and there are other perspectives, the way I look at climate change is as a food shortage. It's not the only way to look at climate change. There's plenty of ways to look at climate change that are valid and real. But when I think about, we have 8.3-ish billion people on the planet at the moment. So we're talking about somewhere between, we'll say 800 million to, we'll say roughly 800 million people, right? That's twice the population of the United States having difficulty getting protein in the diet just because of one aspect of climate change. Sea level rise is another aspect of climate change, which comes from the warming, but is itself a different phenomenon in that, so there's two things that lead to sea level rise. One, when you heat something, that it expands. And two, when you add more to it, it expands. So the ocean getting hotter actually makes the ocean go up. It's just a warmer ocean is a bigger ocean. But when you also wind up melting all of the ice that's on land, and that's like Greenland, Antarctica, for example, those are the big ones that we're worried about. When that ice melts, that goes in, and that winds up, again, driving the sea level up. So we're looking at, a meter of sea level rise. Does that mean Calgary's going to be underwater? Absolutely not. But you take a country like Bangladesh, okay? Bangladesh is going to be really, really hard hit by sea level rise. Why? They've got a lot of people who are living right in that coastal region. A lot of people. Bangladesh is a very, very densely populated country. You look at some of the atolls and so forth in South Pacific, those will actually disappear entirely, potentially, at some point, because the entire island system is just so low lying.
I see.
So we're talking about all of these different things. And let me be clear. We know climate is changing. We know that this is a real thing. And it's not it's not like we're just looking at it and go, oh yeah, the average temperature is getting warmer. That's happening. But the average temperature of land is getting warmer. The average temperature of the ocean is getting warmer. The heat content of the ocean is getting greater. The ice cover is getting lower. We're seeing the layer of the atmosphere closest to the Earth, where all the weather happens. That's the troposphere. That's getting warmer. But when we look at the stratosphere, the next layer up, that's getting colder. Okay. And it's getting colder because the CO2 isn't getting up there.
Oh.
So it's sort of like, if you can imagine, you're lying in bed, you're wearing two blankets.
Yeah. And
then you're like, okay, so the air under the two blankets is warm. The air between the two blankets is probably warmer than the outside room. And the air above that is whatever the temperature. If you switch that lower blanket for a thicker blanket,
then
you're going to be warmer. But the area between the two blankets is actually going to be colder.
I see.
And we're actually seeing evidence of this, where we're seeing that, it's specifically the lowest layer of the atmosphere that's trapping this heat. This is part of how we're so confident that it's specifically the greenhouse gases that are driving all of this change in climate. So when we're looking at all of these, and when I first started looking at this to teach, because I teach about climate change, and when I first looked at it, I was like, okay, so we got like 10, maybe a dozen. There are over 20,000 different independent lines of evidence that all point to climate changing.
Wow.
20,000 independent different lines of evidence that are saying
yes, it's real. And not just it's real, it's specifically real and coming from the CO2 that we are emitting from burning our fossil fuels. Okay? It's really something we're quite confident.
Wow.
Now, are we absolutely certain? Could there be something else? It's possible that we haven't thought of it. Now, getting back to your question of does science work? And here's what I mean by yes, but it doesn't mean what you think.
Okay.
Carl Sagan, who is a physicist at Cornell, had a program called Donev, and he really believed in science communication.
Mhm.
So Carl Sagan came up with the idea that you could make the statement that science always could be wrong, but extraordinary claims require extraordinary evidence. So when did we first start figuring out the world was getting warmer as a result of CO2 emissions?
I, I don't know. Maybe like 100 years ago? I guess. I'm guessing.
It's more like 150 years ago.
I was close.
You were actually
Yay.
you were a lot closer than most people.
Okay.
Most people assume it was like, maybe 40 years ago.
I was gonna say 20 initially, but I rounded up.
20 rounded up to 100.
Yeah.
Good thinking.
Thank
Good
you.
thinking on rounding from 20 to 100. So we first see evidence of people thinking about how we could actually, like the greenhouse effect and how to modify the greenhouse effect within the 19th century.
Okay.
Okay.
Mhm.
So that's before most of the oil development and before almost all of the natural gas development. Not all of it,
Mhm. Mhm.
but before most of it.
Mhm.
So, okay, that goes back a ways.
Mhm.
So when did we become clear that this was happening?
Mhm.
Well, that's more recent. We've had the idea, the model. Now,
Yeah.
science is all built on models. And as you might remember from our class,
I do.
I was fond of saying all models are wrong. Some models are useful.
Mhm.
Models are a deliberate simplification from reality to allow us to make predictions about what's going to happen.
Mhm.
So we have a model for how climate change works, and I'm going to give a simplified version of the model. The actual model that's used for the papers for all this is far more complex, but can be boiled down to the idea we put greenhouse gases into the atmosphere, visible light comes through,
Mhm.
hits the Earth, turns into infrared radiation, which has a longer wavelength, goes back up, and anything with 3 or more atoms in it will wind up bouncing that infrared radiation back down. So if you have 2 atoms in your molecule, hydrogen, oxygen, which is most of the atmosphere,
Mhm.
then the light will pass down and up with no problem.
Okay.
But when you're talking about anything bigger than that, CO2, water's a huge greenhouse gas.
Mhm.
So the light comes down, turns into infrared, goes back up, and CO2 and the water winds up bouncing it back down. We've known about this for, like I said, at least 150 years.
Mhm.
I mean, different people talk about, this, but we're definitely talking mid-19th century
Okay.
that we've known this.
Mhm.
What has come, there's been a lot of refinement to that model. And that model allows us to say, okay, if there's more CO2 in the atmosphere, then we will wind up having a warmer planet. Where that gets tricky is how much warmer and what's up with water. Well, water's a feedback thing. So we put water into the atmosphere, but then it just rains out. Water doesn't stay there.
Mhm.
CO2, once it goes into the atmosphere, if we bump the CO2, how much CO2 is in the atmosphere, it'll take thousands to even hundreds of thousands of years to go back to the normal.
Oh.
You put extra water vapor in the atmosphere, it takes a few days to come back out. Completely different beast. So water isn't driving the climate. There's more water vapor going into the atmosphere because it's responding to the CO2. But this gets into what I'm talking about with the complexity. Makes it difficult for people to wrap their mind. Fourth thing is, it's really, really inconvenient for people to believe that the climate is changing.
Fair enough. Mhm.
Okay? So when I say it's really inconvenient, I want to be really clear. Coal gave us the Industrial Revolution. Oil gave us the modern world. The ability to travel from one place to another comes very much from the internal combustion engine. Humanity owes a great deal of debt of gratitude to oil, to coal, to natural gas. But it's a bit like, there comes a time when sometimes the relationship that has been healthy
becomes unhealthy. It got us really, really far. But if we keep doing it, it's going to end civilization. It won't wipe out humanity. People will not go extinct. Humans will continue to exist as a species.
Mhm.
But our ability to have a city like this where people are, for the most part, well fed,
Mhm.
and we get to do what we want and not spend most of our time looking for food,
Mhm.
that is what can go away with climate change. So our ability to do this,
Mhm.
our ability to drive to work in the morning, live in a building that like we do, or sit in the building like the one we're in right now,
And record a nice podcast.
organize podcasts, that has come as a direct result of our use of fossil fuels.
Mhm.
Fossil fuels gave us that. 5/6 of all of the energy we harvest from nature and use comes from fossil fuels. 5 out of 6.
Mhm.
You can do the numbers in different ways, and those numbers fluctuate up and down a bit depending on how you do your data. But 5/6 is not a bad number to use. So if we want to continue to have the quality of life we have to come up with a way of replacing a coal train 40 times around the earth, and a comparable amount of oil, and a comparable amount of natural gas by weight.
Mhm.
Gas, so it's much bigger volume.
I see.
By weight, it's basically the same.
Okay.
So this is a huge, huge problem. And this is where science doesn't work. Because science says this is what's possible.
Mhm.
But when we start talking about policy is informed by a lot of things other than just science. So science can come to the table and say, if you do this will happen. Here's why this is happening. Science is very good at why. Engineering is very good at how. But neither science nor engineering really covers should. Should, we have to bring a much, much broader sense to the entire table. When it comes to should, we are no longer within the purview of science. We can be informed and should be informed by science.
Mhm.
But what we should do becomes a policy question, hopefully a science-informed policy question. But what we should do about climate change goes outside of just what is happening. So it becomes very, very, very key for people to be able to say, we should do as little as possible because it is personally inconvenient for me to not have access to a car. It is personally inconvenient for me to not take those flights. It is personally inconvenient for me to pay more for electricity to keep CO2 from going up the atmosphere. So when we're looking at all of these things that we should do, that is no longer just a science question. It is no longer an engineering question. When people decide this is what we should do, science and engineering will both step up to the plate and say, let's do it. But until we decide we should do something, science and engineering can only do so much. That doesn't mean that scientists and engineers can't stand up and say, hey, I'm a person too, and I think we should have these policies. But I always want to make that distinction between this is what I'm saying as a scientist, that's my expertise, and I'm advising policy, versus this is a policy question that's going to require an awful lot of nuance. That nuance makes people question whether or not climate change is happening. And there's no question. The world is getting warmer. The climate is changing. It is because of CO2 and other greenhouse gases that we are emitting, largely from fossil fuels. But it is difficult. If we shut off all of our fossil fuels, we will destroy civilization. If we do not shut off all of our fossil fuels, we will destroy civilization.
Oh no.
This is a dilemma.
Uh-huh.
They sometimes call it a trilemma if you throw in a third one. I want to focus just on the dilemma piece of this. The trilemma is worth discussing as well. But for the dilemma, a dilemma is not just a problem. It's not even just a catastrophe. A dilemma is when opposite solutions to the same problem yield the same awful results. And that's what we're facing with climate change.
Oh.
We are facing a world where we cannot simply turn off everything and be okay. We will starve to death. But if we don't turn off everything, we will starve to death. Opposite solutions, same problem.
So then, like, it sounds like it's very catastrophic. What's the solution?
I don't know that there is a single simple solution. And as a matter of fact, there isn't a simple solution at all.
Oh.
But we can bring all the different disciplines to the table and bring our best selves forward and say, here are the choices we can make. Here are the choices that we will make. Here are the commitments that we make. So can we actually get energy from things other than fossil fuels? Absolutely. We do, and we have. 60% of Canada's electricity comes from hydropower, which is renewable and, for the most part, CO2 free. Now, if we want to dig into the weeds of it, yes, there's CO2 associated with it, but it's so much less than what's coming from fossil fuels. Does that mean that every country should switch entirely to hydro? Of course not. Canada has unique geography that makes our hydropower work the way that it does. But I also want to be clear, there have been a lot of atrocities with hydropower. The way Indigenous people, for example, have been treated, specifically around Canadian hydropower, is atrocious in some cases. In some cases, you actually have Indigenous people leading forward very smart, good, well-designed hydropower plants. But when they were first built, a lot of Indigenous people were displaced. They lost their land. There's a whole thing that's happened there. And I feel like I'm giving it short shrift, but I don't want to spend too much time on it because I don't think that's this conversation.
Fair enough.
But when we're talking about Canada's electricity grid, most of Canada doesn't need to change what it's doing. Alberta, though, was getting most of its electricity from coal and went to the trouble of going, all right, we're going to switch to natural gas, which makes a bit of an improvement, but it's a very small improvement.
I see.
Saskatchewan, on the other hand, also getting most of its electricity from coal. So Saskatchewan can also switch. Saskatchewan is looking at building some nuclear reactors, which is something that people are really, really uncomfortable about. But it is one of the ways we can address climate change. There is no one thing we can do to stop climate change. We have to make a series of long-term committed choices to do all of the things. Even if we were to wave a magic wand and make all of the electricity green, we still have cars and airplanes and buses and trucks to contend with. So that's your oil. So it's a complex problem with no simple, straightforward solution. So I can't give you, here's what we need to do in a bullet point list. But what I can say is that it all boils down to, we need to reduce the CO2 emissions, but do it with our eyes open, do it with our heads on straight, and not scream at each other and not pound the table. Because there's going to be losers. And if we do nothing, everyone will lose. Everyone. Like, we're at 2025 right now, as we say this. By 2030, we are going to start seeing food shortages, is my opinion.
Oh, wow.
Now, this is not something from the IPCC. This is not something that I'm seeing widely on the internet. But my opinion, my guess, and I'm not a climate scientist, to be clear. I'm an expert on energy, not an expert on climate. I read climate scientists because I believe they know what they're talking about. They are intelligent people who are working hard and understanding. They are being rigorous. I respect that a lot. And I just want to be clear that while I read extensively about climate change, I don't consider myself a climate scientist. I'm an energy scientist. But when I look at the energy sector, we can make different decisions. And that's what makes my job interesting, is the ability to sit down and say, this is what we're going to do. This is what we shouldn't do. We can make these different decisions. And when we make these different decisions, they have positive consequences in the long term. But they will be expensive. But in looking at all of this, my feeling is that by 2030, so the year 2030, look around in 5 years and see whether or not I was right about there are suddenly food difficulties. And I'm not talking supply chain difficulties, which is what we're facing right now, but actual shortages where, because of changes of weather, because we're getting more floods, we're getting more wildfires, we're getting more droughts, whatever it is, we are going to see globally there just isn't as much food as there used to be. And that kind of famine, and it's going to start with, I think, it's going to start with specific items suddenly getting a whole lot more expensive and a whole lot more rare. My guess is chocolate or coffee.
No!
Well, explain that.
Well, I mean, I quite like chocolate. So why would I thought it was going to be like fish or something. Why chocolate?
Well, no, fish will happen.
Okay.
But not immediately.
Huh.
Chocolate and coffee are both relatively fragile crops. I don't know, it might be something else.
Okay.
Like if you wind up looking at suddenly having a significant shortage of rice, for example, you'd be talking about tens of millions of people starving.
Yeah.
we're not going to run out of rice, but we might not have nearly enough rice. But it's fascinating how when I talk about rice, people are like, oh, that's an interesting philosophical problem. But as soon as I bring up, we might just not have chocolate for a little while. Now, I don't think chocolate.
It gets emotional,
It gets emotional.
Yeah.
It's personal.
Yeah.
Right? What does it mean if I can't have my cup of coffee? And again, I'm not saying that coffee is going to go away forever by 2030, but I predict. Yeah, this is not 100% certainty, right? Like I'm confident the world is getting warmer. I'm confident that 2030 will be warmer than 2025. Okay, that I can say with confidence. But when I look at 2030, trying to Yogi Berra, famous baseball player. Yogi Berra said, predictions are very hard, especially about the future. But I'm going out on a limb here and saying that in 2030, at some point, the entire city of Calgary is just going to go, there's a huge coffee shortage. And you walk into Starbucks, and Starbucks is like, we have this alternative for you to drink instead of coffee.
Huh.
And maybe it won't be coffee, maybe it'll be chocolate. But it will be, I don't know, maybe it'll be bananas. But, I think the whole thing is bananas.
Yeah, it is.
But we are looking at a situation, and I think that's where this is going to get real for people. When you suddenly have something that has always been there. Do you remember when you were a kid, and your parents probably said, "Go outside, it's summer, get some fresh air." Right? Did that ever?
Yeah.
Your parents said that to you?
Yeah.
My parents said that to me too. I used to say that to my kid. My kid's only 14. We no longer guarantee that you can go outside and get fresh air on a summer day in Calgary. And why is that?
Maybe because there's so much wildfires or so much smoke going around. Yeah.
So what you're saying is that while there's still plenty of days during the summer where the air is just fine, there's suddenly a whole lot more days in the summer where the air is different. So it's sort of like the average has shifted.
Yeah, something like that.
And we would call that what?
Change in the climate? No?
Oh.
Okay.
So what you're saying is that the climate's already starting to change.
Yeah.
And within your lifetime, you're noticing that there are differences between the way things used to be and the way things are now. And the extensive, frightening wildfires that we are seeing that are actually changing our ability to just go outside and get some fresh air is something that's already happening. That's what's going to wind up happening with food. We're going to suddenly face a shortage of food that will get worse and worse. And don't get me wrong, I hate wildfires. I hate being stuck inside. But this is the kind of scary thing. And the more personal it gets, the more people are going to wind up saying, oh, we have to do something.
So it sounds like, especially since you brought up the food, like I feel like it's so frightening to think that a lot of people in the future won't be able to get their source of nutrition. That's really scary. And I remember you mentioning earlier that, like Saskatchewan is moving towards more renewable sources like nuclear energy. Do you mind, like, after hearing all that, like, hurting stuff, do you mind talking more about, like, ways that you see forward how renewable energy could work to our favor, like nuclear? I know you have a big background in that. Is that possible in Alberta to also move towards using nuclear? Is it like fusion or fission? And maybe what's the difference?
Let's start with fusion versus fission.
Okay.
Fusion is ramming atoms together to make a bigger atom.
Okay.
Fission is taking a big atom and splitting it apart to make smaller atoms. Both release energy. Fusion is what powers the sun.
Oh, good source.
Great source. Okay. We are probably decades away from commercial nuclear fusion.
Oh.
We're working on it. Very smart people are working on it. Have been working on it for a long time. I would be surprised if we had commercial nuclear fusion within 30 years.
I see. Not an investment thing right now.
It's sort of a holy grail thing, right? Like if we get it, like I wouldn't want to stick my retirement account in that.
Fair enough.
But I'm not saying don't invest in fusion. Fusion's a smart thing for us as a society to invest in. But what happens with fusion is if we get fusion to work, in real ways, in sustainable ways, that's going to be transformative. Like the difference between having the internet and personal computers and cell phones combined versus not having. That's the level of societal shift that having commercial nuclear fusion would cause.
Wow.
It is just globally. It's actually very difficult to communicate how big a deal it would be if we could manage to do fusion. Am I a fan of fusion? Absolutely. But I also recognize that we're talking decades in the future. Maybe it'll be faster. Maybe it'll only be 20 years in the future. But it is a while in the future before we have commercial nuclear fusion. If we can get there, and I really hope we can.
That's going to really, really shift what it is we're doing. Fission, we have been creating nuclear fission to make electricity for about 60 years or so here in Canada. Roughly the same length of time in the UK, roughly the same length of time in the US, France. Like there's all these, there's 30 some odd countries in the world that have nuclear fission. Nuclear fission is not a renewable source of energy.
Really?
It is not. It is a sustainable source of energy. Renewable means make new again. And this is one of the things that I think the left really gets wrong. We do not need renewable energy. We don't. We need low carbon energy.
I see.
Renewable energy, something like wind, for example, is nice because it is energy flowing through the Earth system that we can then capture. And as we capture the energy from the flow of wind, we can then transform that into electricity and do good things with it. That's awesome. But it's intermittent. And we have all kinds of environmental problems from it. That doesn't mean we should not oppose to wind. But it's not that wind is good because it's renewable. Wind is good because it's lower carbon. There is less of an environmental impact. Just because something is renewable doesn't make it low environmental impact. And this is one of the things that people get wrong all the time, because we have, from a policy standpoint, talked about let's get as much renewable energy as we possibly can.
I see.
And part of the background of this is people. So when I was a child, about 10 years old, I was really horrified to discover we only had 20 years worth of oil left.
Wow.
Okay. That was almost 40 years ago. We now have 30 years worth of oil left.
Wow.
So what happens is there's something called the reserve. And what the reserve is, it's how much can we get out that we know exists with today's technology, with today's prices, and still make money off of it. We have to know where it is, and we have to know how to get it out, and make money off of it. So if the price of oil goes up, the reserve goes up. If our technology improves, the reserve goes up. If we find more, the reserve goes up. We are not running out of oil or natural gas or coal in any meaningful way. We just aren't. The problem, so coal, for example, we have 200 years of coal left.
That's a lot of years.
We don't have that much civilization left if we burn that much coal.
Fair enough.
So the great thing about coal is we got lots of coal left. The problem with coal is we got lots of coal left. If we were actually running out of fossil fuels, I would breathe a lot easier.
Oh.
But we don't need renewable energy. What we need is energy that's not emitting so much CO2 into the atmosphere. If, and I don't believe this is going to happen, but if we were able to really master carbon capture and sequestration, carbon capture utilization and sequestration, it goes by different names, but basically you suck carbon dioxide out of the air, you suck it off the top of the smokestack, you suck it out of the fossil fuel before you burn it. However you do it, there's different ways. Again, I don't think that's this discussion. But if you can manage to burn fossil fuels without emitting CO2 into the atmosphere, then fossil fuels are probably a really good idea because they're probably still going to be cheaper than wind or solar or whatever. And I'm sure the people in your comments will actually write out, I've received the life cycle, the LCO, sorry, blanking on what it's called. The
life cycle of like how
assessment of like price and so forth. Levelized cost of electricity, LCO, that's what I was looking for. So the levelized cost of electricity about wind and solar, and it's cheaper than fossil fuels. No, that's not how it works. The reason people keep burning fossil fuels is because under most circumstances, it's the cheapest way to do it.
I see.
So we don't need more renewables. Much of what we need happens to be renewable. We need more solar. We need more wind. We need more geothermal. We need to do as much as we can with the hydro we have, but we can't build the hydro out a whole lot more. We have most of the hydro capacity already built up. So nuclear is a low carbon source of energy that people are like, oh, well, does that make it renewable? I'm like, not exactly. Because it's coming from uranium, and uranium is a finite resource.
I see. That makes sense.
But when we say finite, that implies small. And we have more than 100 years left of uranium, without even getting into strange things like you can harvest uranium from seawater.
Wow, didn't know that.
So, but that's not how we do it, because there's cheaper ways to do it.
Fair enough.
Okay, so we need to do everything. We need to do nuclear. We need to do nuclear aggressively, but we also need to do wind and solar aggressively. We need to do efficiencies aggressively. We need to do a lot of these things. And this is me being policy, science-informed policy. But when I'm talking about nuclear, people are inevitably like, well, sure, but what do you do about the waste? And we have a good answer for that. Canada has a place to build a nuclear waste repository. It got picked this past December, 2024. So it's a brand new thing. They had been working on talking with this community off and on since the 1970s.
Wow.
But they were in no hurry to actually have a deep geologic repository because the waste wasn't ready to be buried underground yet.
I see.
So we're now in a situation, and I was actually, full disclosure, part of that project. I was hired by the local Indigenous community and by the local municipality to serve as their representative to talk with the government and translate what was going on, to be an advocate for the Indigenous people and for the municipality as an expert who understood everything that was happening. The government was saying, the companies were saying, and I've been very proud and very privileged to have been involved in, I was involved in for 9 years.
Wow.
Going out and talking with people. I never thought I would spend so much time in pubs.
Wow.
Yeah, like you just show up and I'm like, all right, give me an entire pitcher of water. I'm just going to stay here answering people's questions until, oh, wait, no, I guess we need a second pitcher of water.
Down.
Sometimes till 2 o'clock in the morning, starting at like 5 p.m., going till like 2 a.m., just answering everybody's questions because people had questions. They wanted to have a willing and informed host community. And that's what the federal law said. They said, in order for us to pick a site, they have to demonstrate that the community understands what it is they're doing and that they are actually going forward. And 76% of the municipal community actually voted yes. And the Indigenous community had a separate vote, and they also voted yes, but it was a closed door process. We don't have as much details about that, nor do I think it's appropriate for us to.
Fair enough.
But they were very clear in saying yes.
Wow.
So Ignace demonstrated we understand what's going on, and yes, we want to do this. So Canada has a great story about how we're doing nuclear waste. We're involving people, we're conversing with people. We don't have a solution for climate change yet. We have a solution for nuclear waste. So I believe nuclear is an important part of fighting climate change. I believe solar is an important part of fighting climate change. I also teach the solar power class.
Oh, nice.
I also have taught the hydropower class.
Oh.
I have never taught the wind power class, but even though I've never taught it, wind is also an important part of fighting climate change. But we're not going to simply get rid of fossil fuels. We just have to reduce how much CO2 we emit, either through reduction of fossil fuels, reduction of emissions. It's not simple. It's not easy. And because it's not simple and it's not easy, and this gets to my final point about why are people so reluctant to believe in climate change, it's easy to feel helpless. It's easy to look at the scope of the problem and say, there's nothing we can do. But there's lots we can do. We need to find the willingness to do it. That's not a science question. The science is working. The science is working just fine. And if we're wrong, science still works. If the reason the world is getting warmer isn't actually the CO2, then anyone is welcome to sit down and come up with why the 20,000 independent lines of evidence that have supported what it is we think is going on. If someone can come up with a better model, they are welcome to do so. But people have been trying for decades, and no one has a better model. Science still works because we're still open to being wrong. But open to being wrong isn't the same thing as being wrong.
I think that's a really positive note to end it all off on. We talked a lot about climate change and its importance, and then about what we can actually do about nuclear and its future. And I want to say thank you for taking the time, and I've learned so much from this conversation. So thank you so much for teaching me.
Thank you for having me.
Yeah, thank you, Donev.